Okay, so here are two examples where we have to use the chain rule. Because these are nested functions. Sine x is nested inside the square function, 3x is nested inside the e of the x function. And one way to easily see that it's a nested function is to see if you can kind of replace some parts of it to a big X and make it look like a regular function. So, for example, let me try to do this. Okay. Here I'm going to put a large X. Okay, large X. And I'm going to cover this. Well, it's not covering very well, but if I put this, use this X to cover the sine X, what do you see? It's X squared, right? So X squared is the outside function, and what I covered with X is the inside function. That's how you see it, okay? If that pattern is seen, when you differentiate, you have to use the chain rule, okay? So let's try this. I can replace this 3x by x, right? If you cover it, what function do you see? You see e to the x, right? What is being covered? 3x is being covered. So what's the outside function? E to the x is the outside function, and 3x is the nested function. It's the inside function, okay? That's very important because the chain rule says you have to differentiate the outside function, leave the inside as it is, and then pull the inside function out and differentiate. That's what chain rule says. That's what this chain rule is saying. Right? Okay. So you differentiate the outside function, inside function stays as it is, but then you have to pull this inside function out and you have to differentiate it. Okay? All right. So let's try to do this. So first, you differentiate x squared. What do you get? It's 2x, right? So you have to say 2x. 2x, okay? But what is this x? It's the sine x. The one that I covered is sine x. That's sine x. And then I pull this out and differentiate. Where this x is again is really sine x. Okay? That's how you apply the chain. Make sense? All right, and then you do 2 sine x. Sine x differentiates to cosine x. That's it. Okay. It's not that easy. You really need some tools like this to be able to do it. I mean, what I sometimes make students do is, if you have trouble understanding it, then take your thumb, all right? Take your thumb and put an X there. Okay, just put an X mark with a ballpoint pen. And then try doing this exercise of covering, pulling it out, pulling your thumb out, and then differentiating your thumb. Kind of works, okay? So if you have trouble doing it, that's a good strategy, right? So let's try this again. Okay? So e to the x is the outside function. What do you get if you differentiate e to the x? E to the x, derivative of e to the x is still e to the x, right? So you still get e to the 3x, but then that x has to be pulled out and differentiated. So this 3x has to be differentiated. What's the derivative of 3x? 3. That's how you do it.